You are about to bear witness to the best WordHunt player in existence. It's not a man, or woman, or even a human. It's this 3D printer. WordHunt is an iMessage game that I like very, very much. The premise is simple. You get a 4x4 grid of letters from which you can connect a line to form words. The longer the word, the more points you get. You send the game to your completely real friends and the higher score wins. Very cool. This game is extremely addicting. Anytime I have 80 seconds to sneak in a game, I do. Taking the trolley? WordHunt. Between bench sets? WordHunt. Boring funeral? WordHunt. You get the idea. Anyways, let's write an algorithm to solve all the words. First work of order is getting a list of every single word in the game. Doing some googling, it doesn't seem there's an official word list floating around. So I settled for the 2019 Scrabble official list of words. This list included 2-letter words, whereas WordHunt does not, so a little bit of cleaning was required. Now that we have a list of words to search for, what strategy do we employ to algorithmically find valid words? One might think to find every possible combination of letters in the grid and check if they're in a dictionary, but this is a terrible method to find all the words efficiently. You see, with this grid, this method would search for WDHD, which clearly is no word. It then would append another letter, in this case M, and search again, despite it being pretty obvious to us that there's no possible word starting with WDHD. We'd want to stop the execution of this search when we know there's no possible words that can be made. This is where the try data structure comes into play. It's a prefix tree that's commonly used for this exact case, determining what words could start with a prefix. It's a sequence of nodes and edges, where the node solely holds a Boolean value that stores whether or not the path to traverse to it is a word. The edges hold letters that are valid paths to other nodes. This example shows a try that holds cat, car, and cart. As we can see, the finished path for each word holds a true value. If we wanted to see if the word corn was in this try, we would traverse along the C edge, notice there's no O edge, and return false. If we want to see if there's words starting with car, we would traverse those edges, then return true since there is an edge after this node. This represents the prefix exists function, which allows us to prune searches, making it much more efficient than using some sort of set data structure. So, with our program, we create a try structure with all the words in our list. We then run depth first search from every letter in the grid, adding words to a bank when we find one, and stopping searches when there's no words that can be made. With each word we add, we also keep track of the path we traveled for every word so we can solve for it later. Now we just input a grid of letters and boom. There is every single word we can make from the grid, sorted by length. As you can see, it's a really quick algorithm. Most of the time is spent constructing the try from the absolute behemoth of a word list that we've downloaded. I'm sure we'd be able to store the actual try itself in order to skip the construction phase every time we ran the program, but since it's so quick, I'll just skip over this. Now I want to make a program that plays the game for us, solving for each of the words we found. I started this by creating a script that drew over a picture to show how to solve for a given word. All we do is convert a path given in our solver program to a list of coordinates that we connect the line between. Wicked! This visually verifies to us that we are solving for valid words and we are correctly storing the path to traverse. But at this point, I have to manually enter a grid to solve for. Let's fix that. For this, I get a screenshot of the game, run it through a quick enhancement that filters out everything that isn't black, then give it to PyTesseract to return the text in the image. Since the text in our image is super clear, it'll have absolutely no problem. What? Honestly, it baffles me how this text isn't accurately recognized. I tried running it through every config option, but each one comes with its own issues. Whether it be seeing P's as D's, seeing I's as this thing, seeing double, or just flat out returning nothing. It was really frustrating. I got to a point where it's working about 90% of the time by cropping each letter, analyzing it, then running it through a bunch of if cases based off the common errors I was getting. Really janky, but it kind of works, so I'll rock it. Now I wanted the program to actually solve the words for me, so I didn't even have to touch my phone. All we have to do is remotely control my iPhone. Problem is, Apple doesn't allow any sort of remote screen control, which is probably for the best. After a lot of searching, it turns out there is sort of a workaround for this. There's this really shady Chinese app, My Phone Mirror 2 Lite, wow, that claims to allow remote control of the phone. After watching a lot of the videos, I really couldn't tell if this was just a scam since 99% of the videos showcasing the app were in foreign languages, and all the comments said it didn't work. So naturally, I gave them my card information and $7 to verify myself. Turns out it does work, but it's really slow. To my understanding, the way this application remotely controls the phone is that it basically turns your PC into a Bluetooth mouse, then sends instructions to your phone based on your actual mouse. But with this, we're actually able to solve for words on WordHunt, no hands required. Instead of drawing over a screenshot, we instead feed the coordinates to our mouse, holding click whenever we are solving for a word. And there it is. As you can see, it can't go super fast as it's limited by how laggy the remote access application is, but it can solve the big words sometimes. It still gets pretty high scores, around 30k, but that's nothing too insane and completely human attainable. I want this solver to completely max out the score and baffle my friends. I thought up a few different ways of going about this. One was to get an Arduino, connect it to my phone via Bluetooth, and spoof a mouse, essentially doing the same thing the remote access application was doing, but we wouldn't be limited by the lag of it. This is cool, but it's not that cool. How about we actually physically solve for the words, but with a robot? I was thinking of creating or buying a 2D plotter, but since that'd be kind of expensive for just a singular project, I didn't want to do this. That's when I realized I finally had an excuse to buy a 3D printer. I've always wanted one, but could never justify the price. But now, I can use it as a tax write-off. If you really think about it, a 3D printer is basically a 2D plotter that can move in an extra dimension. So here's the plan. Print a custom fitting for a stylus that attaches to the printer head. Generate custom G-code that moves the stylus to solve words. Destroy my friends. I've never actually used a 3D printer before, so I don't know if something like this will be feasible for a beginner or even possible, but I guess we'll find out in about 3 days time. And boom, it's here. And she's a beauty. A few test prints later to learn the slicing software, and now it's time to model the stylus holder. I modeled it to mount on this screw, which I don't know the purpose of, but hey, it can't be that useful. After one prototype, it seems to be pretty solid. Next, I need a way of securely holding my phone to the bed. And after consulting my buddy Jordan, he quickly sent me this super high-tech mock-up, which I quickly modeled in Blender. It fits perfectly on the printer, but there's a small gap on the top and bottom of my phone. But this isn't an issue since it squeezes my phone on both sides, leading to no movement when touching the phone, so it'll do. Now, I need to create a custom G-code file which converts the coordinates from my solver to 3D coordinates the printer could interpret. This means I also had to learn G-code, and by learn G-code I mean learn a singular command, move. This can either use relative or absolute positioning. I chose relative since to use absolute the printer would have to run through a homing process to figure out where it lies in 3D space. Relative just means the movement instructions for the printer are based on the current position of the head rather than a static coordinate system. I measured the size of each letter on the board, coming out to 11 millimeters, and using some really basic math, I was able to create a path for the printer head to move based on a word. We lower the print head at the start of a word to begin touching the phone, then raise it back up when transitioning to a different word. Now that we generated a custom G-code file, I had to actually get it onto the printer. To my knowledge, the network adapter for Bamboo Labs printers is proprietary and closed source, so I can't actually print it directly from my computer, which is kind of a bummer. Please fix. Instead, I had to use FTPS, a file transfer protocol which can send files wirelessly. I use this to transfer the custom G-code file from my PC to the printer, from which I can use the built-in display to start a print. It sucks to have a manual step in between creating the G-code file and starting a print, but I was able to get the file up and running on the printer within 10 to 15 seconds of starting my solver program from the beginning. So, all that's left to do is to test it. Alright, let's get this up and running. I'll run it through the whole process here. I got my phone screen mirroring to my PC, got my solver application open. I redesigned the pen holder since the old one would rotate sometimes when doing test prints, and it also started like having a prolapse, for lack of a better word. Sorry. Yeah, so I basically designed a second one to keep it very rigid to the printer head so we won't encounter that rotation. I'm really nervous to try this because I don't want to break my phone or the printer, which is a very real possibility if I have somehow messed up my math. I did a few dry prints with my phone next to it to make sure it wasn't going to crush it, and it seemed fine, but the real thing is so much scarier. Alright, so the first thing we actually have to do is to home it. Basically put it in the position where it's going to be right above my phone. So I just made a really simple startup.gcode. Alright, and that should be in a position right above my phone. And I put the stylus holder in. Alright, time to clip my phone in. So we just slide it in from the side. I usually pull up a screenshot of the game to get it lined up all correctly. Alright, and that looks good. Alright. Oh, man, deep breaths. I'm nervous. So, we basically want to click call all, which will get the board, find the words, and generate the G-code and send it wirelessly over. So I'll just hover my mouse over that. So as soon as I have that screen up on here, I want to click it. Okay. The G-code should be generating right now. We'll know when it's here when the screen refreshes. There we go. Oh, come on, baby. I'm like actually shaking a little bit. Oh, that is so cool. Look at that. Is that not the coolest thing you've ever seen? That is so sick. I don't think it's messed up any words yet or solved for any that don't exist, so I think we got a good board for this. I think it is going to run out of time. We're only at 20 seconds left right now before it solves for every word because it's still on the 4-letter words. But, I mean, you're not going to find anyone beating this score regularly, so I don't think we have to worry too much about completely maxing it, but so cool. Okay, now I can just manually end the print. 47,800. The top word was Turdians. Nice. That was actually such a relief. You could probably tell how nervous I am. I was so afraid to put my actual phone onto the printer head or onto the print bed. Actually, such a relief. Anyways, I think I'm going to run this a bunch more times to try to see the max score I can get, try to completely max it out. Of course, gonna send it to all of my friends and completely destroy them, which I think will be hilarious. Yeah, here's gonna be a little montage of it. Thanks for watching. This was probably the most fun I've ever had on a project, and I hope you guys enjoyed it as well. If you did, like and subscribe. And thanks for 20,000 subscribers. It really means a lot to me. I never thought I'd make it this far, but here I am just buying a 3D printer for a video. As for the solver, it averaged about 50,000, which is insane and will completely destroy 99.999% of players. I have a few ideas on improvement, including increasing the speed of the print head, as well as minimizing travel time between words. I currently have it at 500 millimeters per minute, whereas 30,000 is the max. I tried increasing it to 750, but the stylus started slipping and it wasn't registering and it just had a whole slew of issues. If you guys have any ideas to increase the score or just ideas for future projects, especially with the new printer, let me know in the comments. I'll try to read as many as I can. As always, the code will be provided in the description, and I hope you have an epic rest of your day. Bye!